Yes, ma'am, we can start, ma'am.
Okay, sir.
Thanks.
Very good morning to all. Today is our resource person. One second, please. Sir, am I audible?
Yes, ma'am, you are audible, ma'am. Please go ahead.
Okay, sir. Very good morning to all. Today's our resource person is Professor Kiran Kumar, Department of Computer Science and Engineering, New Horizon College of Engineering. So I would like to welcome our today's resource person. Welcome you, sir.
Thank you, ma'am.
Now the session is handed over to our resource person. Please, sir.
Thank you. So, good morning to all the respected professors. I would like to thank Excel Engineering College, the Department of Computer Science Engineering principal, and all the organizing committee for the given the opportunity for me to participate in this short-term training program. I'm really happy and privileged to be part of this program. So let us see. So here the topic given for me is um the introduction to Hadoop distributed file system and MapReduce framework. And here morning session. I'm going to take the morning session. I'm going to focus on HDFS, that is Hadoop distributed file system. MapReduce framework. So here once again I welcome. This is our slot number 2. Slot number 1 held in the month of December 15th, and here the slot number 2 from yesterday it started from 4th to 9th Jan. Today is day 2. The topic given for me is Hadoop distributed file system and MapReduce framework. Um, so as I said, morning session, I'm going to talk about HDFS, and followed to that afternoon session, I'll be discussing on MapReduce framework. So outline for morning session will be before I start with HDFS or Hadoop. I would like to explain something about the big data analytics. Why this Hadoop came into the picture, and why the industries are behind the Hadoop concepts, Hadoop framework to use that Hadoop concepts to their organization. So let us try to understand the meaning of big data analytics. I'm going to describe what is big data analytics, and follow to that what are the types of analytics available. And after that, I'm going to play a small video to understand how the big data transformation happened. So how we are facing that huge amount of data, what are the technologies is required, what are the different types of skills is required from the student community to overcome those limitations. And follow to that, I'm going to explain what we have the problems, what is the problem with the traditional approach. Before we step into the Hadoop, let us try to understand what are the problems with the traditional approach. Then I'll be explaining why the Hadoop has come into the picture, what is Hadoop and Hadoop components, architecture, HDFS read or write operation, video. Finally, before ending today's morning session, I'll be playing a small video about one of the analytical example in the education system that we call the education analytics. So how the education system, how the education industries are using this big data analytics to overcome their drawbacks. So I hope this is clear. And here, these are the outline for today's morning session and the outcomes. So here, if I speak with respect to outcomes, so the participants will get all these 4 outcomes at the end of the morning session. The first outcome will be you will be understanding some of the problems with traditional approach. What exactly the problems what we are facing in the traditional approach, and follow to that you'll be understanding how the data growth, what are the different sources of data we are getting, and how the data generation and what is the importance of data. That will be the second outcome. And third will be understand the Hadoop framework. So once we understand the drawbacks of traditional approach, and once we know about the big data analytics, then we can know about the Hadoop. So here we are going to understand the Hadoop framework, its components, architecture, and the read write operation. Once we start explaining the Hadoop architecture, obviously we should know how this inner functionality happens, how the read request happens, how the write request happens. So everything we are going to understand here. That is your third outcome. And the final outcome will be you'll be in the position to understand the real-time analytics, how it happens, based on some case studies what I'm going to give in between, and also based on the video what I'm going to play. So these are the four outcomes. Positively, all the participants and all respective professors will be getting at the end of morning session. So initially, to start with this, let us try to understand what is big data. So the name says it's a big data, but when we describe the big data, what exactly it means? Here, taken some of the tool definitions from the textbook. So here you can see that the big data are the data sets that are so big they cannot be handled efficiently by the common database management system. So the amount of data here, they are specifying the amount of data which is so big that cannot be suited with the normal traditional database management concepts. So that we call it as a big data. And here you can see the second definition, which says whenever you speak about the big data, the volume of the data should be minimum 100 terabytes to petabyte. And the amount of data what we collect, the amount of data what we call like 100 terabyte or more than 100 terabyte. So all the data will be a combination of different types of data. So I can say it's have the structured data and also have the unstructured data, so which has a constant flow. So here three terminologies they have mentioned. One is the amount of data is very big, and followed to that the type of data what we collected also it is a different one, and the speed which comes to the system, which has a constant flow. Every time the constant flow is coming to the system, so we need to have some kind of technology to capture those data and to perform some kind of analytics over the data. So with this two basic definition, we can conclude that really the big data is a bigger one. And here one question will come in our mind is, from where exactly this big data is getting generated? Okay, so here we understood the size of big data. With if it is more than 100 TB, then we can say it is a big data. But exactly where the different sources, such huge amount of data is getting generated. So if this is my question, where this big data is coming from? Is there any answers from the participants? Any guess or any idea from where exactly the big data is coming from? Anybody would like to answer here? Where a huge amount of data is coming from? Which are the different sources?
Internet resources.
Internet resources, yes, as madam rightly said. So here most of the data which contributes to the world is from the mobile planet and the IoT. So these are the two major sources, I can say. It's not only within these two sources, but it is a major source where the huge amount of getting data is getting generated. So let us try to understand how does the amount of data which is contributing to the world right now. So here one of the statistics which is published by the industry, the business intelligence team have been published this statistics here. You can see here x-axis and y-axis. X-axis is with respect to the year, and y-axis is with respect to the number of connected devices. See, we all know that the IoT is born in the year between 2008 and 9. Okay, so after that 2008 and 9, we can see how much data growth has increased. So year by year, the amount of data is getting increased a lot. And you can see here even the with respect to the number of connected devices. See, whenever the data is getting increased, because obviously there are many devices available, there are many smart devices available. We introduced the smartphones. We have a different variety of smartphones. Each smartphone has a number of sensor devices available. So each sensor device generates some kind of data. Even if you take IoT, everywhere we speak with respect to the city to become a smart city, or we call the smart traffic control system we need to build. So everywhere we are trying to make it as a smart, but at back end it generates a huge amount of data also. So from this statistics we can understand how the data growth has taken place, and from which particular source the huge amount of data is getting generated. So as the graph explains here, the IoT, Internet of Things, so the devices, the smart devices what we use here, from this the huge amount of contribution will be taken place. And next to that we can see the smartphones and the tablets and all the remaining small devices are the small the industries where the generates huge amount of data. So this is one statistics itself explains us how the data growth is taken place every year. And obviously we need to have some kind of technology to handle this data. So still we'll try to understand some of the data generation, some of the data source which we feel day-to-day life, which we experience in the day-to-day life. So most of us know the Walmart. So it is one of the American multinational company which runs for the departmental store. Worldwide they have n number of branches. So Walmart handles more than 1 million customer transaction every hour. It handles 1 million transaction. Just think about the product which they buy, the individual customers. So there should be some kind of technology should be available to capture those data, to warehouse the data, and to handle those data. So this is one of the example which we feel every day whenever we go to the grocery store. Obviously there will be some kind of data will be generated for our product what we have purchased. And we can see here web data, e-commerce, and purchase at the departmental grocery store, the local shops what we go. So every time nowadays it becomes very straightforward. Whenever you go to any shop, they ask you to register yourself. So they ask us to register ourselves. So we will obviously we will give our basic information. We give our mobile number, that is a basic requirement which is required, and the name. So by that they'll create an account for us. So whenever we go and purchase any product in the grocery store, what happens, they try to capture all our information and they'll store it in a warehouse. And the bank transaction what we do day-to-day life, and social networks, so the social networks whatever we use. So all this from the different source, this we call as a day-to-day life activity, what we do, what we experience in the everyday life. So even here a huge amount of data will be getting generated. Yeah, so let us try with some more examples to understand where exactly the big data is getting generated. So as you can see this slide, big data is too large and too complex for conventional data tools to capture, store, and analyze. So here the problem is not only that data which is coming. So we need to capture, that is our first task. After capturing the data, we need to store and we need to analyze. So analysis comes at the end to get some insightful information to give the benefit for the customers and also for the companies. So here to describe this big data, again I come up with some 4 examples here you can see. So one of the examples, share trade of US stock market exchange which generates 7 billion data every day. And here you can see one of the source called as a flight from the international flight, one of the flight which flew from New York to London, from the single flight which generates 10 terabytes of information. So just calculate like how many flights every day it runs between the countries, between the cities, and between the states also. So just think about how much data will generate from one source, that is the aviation department. So aviation department itself, they have very huge amount of data source will be there, and they have a separate data warehouse where they store all this information. And here you can see the number of tweets per day on the Twitter, 40 million, and number of likes each day on the Facebook, which generates a 3 billion amount of data. And these are some of the example which suits exactly to the big data. And here you can see 90% of data, some of the industries they climb. So here in the year 2006 there were only 0.18 zettabyte of data were available in the world, but within this short span, you can see the 10 times fold happened. So from 0.18 to 1.8 zettabyte in the year 2011, within 4 to 5 years, when they introduced when the Internet of Things was born, and also the smart devices were getting increased. And here some of the textbooks and some of the internet material says that so we can describe the big data by using 3 V's. As I told you, the big data has we understood that the big data has a huge amount of data which range from 100 terabytes to petabyte, and also it has a different structure and they have the constant flow. So these 3 explanation we can give, we can relate, or we can correlate with these 3 V's. Let us try to understand what this 3 V's says with some example. So here I have given a 3 pictures to understand how this 3 V's is going to define this big data, describe this big data. You can see towards the left hand side to my presentation. So here the traditional, just we are trying to compare the traditional versus big data. So with respect to volume, here the volume describes the amount of storage, the storage space is required to store the big data and required to store the traditional day-to-day transaction. And variety, here the variety means the type of data what we receive. So whether it's already in the structured or it has a different type of data, like maybe the images, audios, videos, log files. So we call this a variety of data. And last one is velocity, in which flow, in which speed the data is coming from the different source to our system. So let us try to understand these three V's by using this small example here. So here the example, the first example explains to store our traditional data, the day-to-day activity, day-to-day transactions, the required amount of storage is very less. But as we understood the big data, which generates a huge amount of data, there should be some technology to store the huge amount of data. So we need a storage space, or we call it as a data warehouse, or we call it as a servers. So we need some space to store a huge amount of data. So that with respect to volume. And when you see with respect to variety, the middle of the presentation, you can see here the traditional database has already the data which we have put it in the structured format when we call it as a rows and columns. But big data has a different type of structure which has the images, we have the audio files, we have the video messages, we have the log files, we have all the different types of data available in the big data. Most of us we are experiencing every day, right? So whenever the wishes message comes in the early morning from different colleagues or different relative people, what we do, we used to forward the messages. Sometimes the messages will be a text message, sometimes the messages will be combination of both text and image, sometimes the message will be an animation, sometimes the message will be a video also. So we are the one who we call it as a data agent. So all the individuals in the country are called as a data agents, because we are the one who also generates the data. And here towards the right hand side, you can see here I've given a small picture to understand how the flow of data comes into the big data and the traditional approach. Just for understanding, I've given this diagram. So the traditional database has a constant flow, or I can say it comes in the interval basis, like very less amount of data will come into the system where we need to capture and we need to analyze. But when it comes to the big data, so huge amount of data will come, and also the speed in which it comes to the system will be unmeasurable. And we need to have a kind of technology there to capture the data dynamically. So here one example I can give, maybe when we use the Amazon. So most of us, we are familiar with e-commerce, Amazon. So whenever you start purchasing any product in Amazon website, Amazon e-commerce site, so what happens, Amazon purely performs a data analytics, big data analytics. So they will try to capture all our information bit and pieces. So for the example, I'm the user, I'm entered into the Amazon right now in front of you. So whenever I entered into the Amazon, obviously I've logged in, my Gmail account is already synced with the Amazon. So Amazon is one at the back end. They started collecting by using some of the analytical tools. They start collecting all my information. They will come to know at what time I have logged into the Amazon. Now the time is 10:10. So the Amazon will capture that information. I have logged in at the 10:10, and where I landed there, in which particular page I have landed. Just assume I have landed into the page called as electronics device. So where I'm like to buy a laptop. So they will capture that information. Even if see, usually what user does, user will go and they will compare the product with respect to the configuration, with respect to the price, with respect to the different types of technology what the laptop has. So what happens, whenever I used to compare the different products, even those information also will be captured by the analytical tool. So just think, after I compared all some 4 to 5 laptops, I selected the best one. What I made, I selected the best one, I pushed that product to the checkout page. I made that product to push to the checkout page. Okay, so that will be another page, another session has been started. So even that information also will be captured by the analytical tool. And what happened, by due to some reason, what I did, I planned, my mother and my father have suggested me, why can't you compare the offline store? So what I did, just I put the product which I shortlisted, I just pushed the product to the checkout page, and I came outside of the Amazon. What happens now? So at the back end, the analytical tool it's more clever, saying that it comes at the conclusion that this is the product I have been shortlisted. For sure, the customer have liked this product, and somehow they have to push this product to the customer to buy this. So this is one scenario. After I logged out from the Amazon, what I'm going to do, I'm going to immediately go to the Instagram or the Facebook. Just an example. So what they do, they perform the real-time analytics, they capture all this information. You might have come across all this experience, the same product, the same laptop, at the different laptop, what I have compared, the same product will be coming as an advertisement for you, coming as a notification for you, either in the Facebook or the Instagram or the different social media sites. So they try to publish, they try to push the same product, and they'll try to remind you, they try to make you to buy the product. So this is one of the case study or example I can say, to understand how fast the data are getting captured and how fast we need to perform the analytics. So that is how the big data here. So just I have explained about one single customer. Just think about how many customers they log into the e-commerce at a time, and how many customers data they have to capture, how they need to process the data, and how they need to improve their business. So here purely it speaks about the data, the amount of data what they capture, and the real time, in which time, in which exactly, in which flow they are going to collect the data to make the business more effective. And here also comes one example, like how the devices, how the number of connected devices with ratio of world population. So you can see here we have one small statistics which is published by the Cisco in the year 2011. So as I told, the Internet of Things was born in the year 2008 and in between 2008 and 9. And we can see before to that, maybe the example 2003 year, you can see the world population was 6.3 billion and total number of connected devices was just 500 million. And after this IoT, after this born of IoT, you can see here in the year 2010, the population was 6.8 billion, but the devices, just see the devices, the growth in the devices is 12.5 billion. And here if you see the ratio, in each person will have on an average they will be having 1 or 2 devices. And the years to come, maybe you can see in 2020, so number of devices available, connected devices available in the world right now, it will be more than 50 billion, and the population is just 7.6 billion. And in the ratio you can see, on an average each person will be having more than 6 to 7 devices. It need not to be a smart devices, or it need not be a mobile phones. We can have any kind of smart devices which generates the data, maybe your smart watches, maybe if you have any smart locker in your home, if you are using the smart devices in your home, everything comes into the picture. So with this few examples what we have taken, we can understand really the data, the big data is getting increased in the country, in the world, and we need to have kind of some technology to handle those information. And here's some more example. Facebook generates 10 TB of information every day. Twitter generates 7 TB of information every day. So we know how many users, how many new users are getting registered every day in the social sites, and how much data we generate, how many posters we are going to put in this social media sites, and what are the videos, different videos, images, text messages, all the combination of messages we are going to put here. And here sometimes IBM claims, most of the industries they claim the 90% of data what it is generated, it was just from the few years, from last 5 years or 6 years or 3 years. So this is what the industries are speaking about big data. And here, from till the previous slide, I've tried to come up with some good examples here to understand, to make everyone to understand like how the huge amount of data is getting generated, what are the different source the data is getting generated, and really there is a question mark that we need to have some kind of technology there to handle those information. And one way, this is one question mark, and second question mark will comes in our mind is that what happens, why we need to capture this data. Okay, after I capture this information, what I have to do, what is the use of capturing this information? To understand that, let me give a small example which suits for our profession. So always as a engineering college, we used to collect the students information. So there will be a ERP system will be there, and we'll be having some kind of format where we used to collect the information from the student side when they register themselves there, when they get admitted to first year, what we do, we used to collect the information from the student side. So what we can do by having those information, for example, if I have a in an institute, just let us assume we have 4,000 students. Okay, we have a 4,000 students information in our system where we call it as a ERP. So we have collected that information. So what we can do by having that information is the question comes to answer that question, we call it as analytics. So by having the information as it is, I collected, I warehouse the information, but I'm not going to do anything for that information, then it is useless. Okay, so let us try to understand what is analytics and how it is going to fetch the benefit for us. Okay, so as I told, data on its own is useless unless you can make some sense of it. You just collected the data, where is the data, then it is useless. But if you go and take some information, some insights out of that data, it makes some sense. So what is analytics? So we are trying to understand what is analytics here. So analytics is nothing but a scientific process of transforming the data into insightful for making better decision. What kind of decision we can make? By having all the students information with me. So what I can do, I can predict the student performance. One of the example I can say, by having their previous history of records, what we can do, we can predict the student performance for the coming semester. Or we can say, we can offer the new opportunities, maybe for the students community. By understanding their requirement, what we can do, we can come up with some kind of seminars, some kind of guest lectures, we can come up with some kind of workshops for the students. We can create a new opportunities for that, for the competitive advantage. This I have taken only for example of the education system, but industry is very large. Almost all the industries, 10 in 8 to 7 industries already they are using this concepts, the data analytics concepts. So I hope from this slide we understood what is big data and also what is analytics. So by putting all these three words together, big data analytics, so there is something behind this concept where we need to have some technology to handle this and to perform the analytics. So the next slide here I'm going to show is what are the types of analytics what we have. So again, the days to pass, they have come up with the different types of analytics, but as I suggest or I wish, these are the three analytics briefly can be described, and from this again, if you want to inherit later, you can able to justify yourself. And here the types of analytics, we know we have a data with us. When you perform the analysis, when you perform the analytics, what are the outcomes you'll get? There are the three outcomes. One is prescriptive analytics, second one is predictive analytics, third one is descriptive analytics. So let us try to understand what are these three types of analytics with small example. So here the prescriptive analytics says, what should we do? But we have some kind of information. So let us assume one, maybe the real-time example or some example I'll try to give here. So for example, I am sick. Okay, I'm not well. So what I do, I just observe for 1 or 2 days, but still I feel sick. So what I do, I just went to the doctor and I met the doctor. What happens, the conversation between the doctor and the patient? So doctor will start asking some questions. Where exactly, how it started, what you had, what kind of food you have taken before the symptoms. So what happens, there's some kind of historic data discussion happens. Doctor is trying to identify what happened to the patients before he or she felt the sick. So here what happens, by understanding what happened, the doctor will come with a prescription saying that to overcome or to reduce the sickness. So same thing here, what should we do? By understanding the data, the historic data, what should we do? So it gives the picture for you, it gives a clear path for you what you can do by understanding the historic data. That is nothing but a prescriptive analytics. You need to analyze the historic information. Here comes the predictive analytics. What could happen? What could happen says about the predictive analytics. So you have the data. After analyzing the data, you're coming with some kind of prediction model where what could happen in the future. So for example, I told you about the student prediction, the performance prediction. So here the student performance prediction says you have, for example, the students currently they're in semester 3. So they're approaching the final semester end examination. So what we can do, we can have kind of prediction model there where all the historic data will be analyzed. The students historic data from the 10th SSLC, from the +2, from the semester 1, semester 2, all these grades or the marks, how he is attending the classes, attendance performance, everything. By collecting all the attributes, what we can do, we can come up with a prediction model where we can predict what could happen in the final semester exam of all the students. Why we do that? So just assume next month we have a semester examination. This month you have come up with some kind of prediction that out of 4,000 students, around 3,200 students will pass or will get average marks, and the remaining 20% of students will get above average marks, and remaining 10% students have need some kind of attention is required. So by having all this analysis, you have categorized into three. One is average, above average, and the poor. So the students who falls in above average, kind of motivation is required to push them to get maximum marks. The students who are at the average, so this is the postmortem. After you have the prediction model, what you can do, you can come up with some kind of plans to address these issues who are in the least side, who are need some kind of assistance. So we can have kind of an tutorial classes, we can have some kind of extra classes to make them to clear the paper to get some average marks. So below average to average, we need to push the students. What are the actions we can take in place? So this prediction model says what could happen. So if you do that analysis, obviously our performance will increase in every semester. This is one example I have given here. And descriptive analytics. So here what has happened? Okay, so one example, let me go with the next slide because we have some interesting examples here. Okay, let me go in the reverse order. The first, descriptive analytics. Most of us, we are familiar with YouTube's, Netflix, some of the engines where we feed our data and we have seen the results. So just assume in a YouTube, you have just went yesterday, you logged into YouTube and you have searched for some of the educational videos. And based on your search, based on the previous search, what happens next time when you go freshly to YouTube? Just assume that today you are going to log into YouTube and you're trying, once you immediately log in, the system itself recommend to you some of the videos based on your previous search. Just we call it as a descriptive analytics. How does Netflix frequently recommend just for the right movies for you? So based on the category what you have selected, the movies. So next time whenever you go with a fresh, what happens? It gives the recommendation for you to go with such based on our previous search, based on our likes and dislikes. So what happens? It gives the recommendation. So we call it as a recommendation model here. And the next one, as I told, the prediction model, one example I've already given. And one more example, most of us, we come across this example. So whenever we go for purchase, maybe the shops where we go to buy our clothes, just assume we have just went with some of the brand factories, some of the branding shops. So what they do usually, so whenever they have the recession in the sales, so they'll come up with kind of sales. Okay, they give the advertisement, they give the public newspapers, they will give all the articles, they'll try to publish. They say that, so if you purchase for this much, for example 3000k, so 303k, so 3000 rupees, if you are purchasing for the cloth for 3000 rupees, you will get 50% discount. So this is the view what we get. But once you go inside, when you purchase the clothes, finally when you come for the billing section, what they do, so 50% discount, out of that 50%, they will give 30% directly, they deduct from the total cost, and the remaining 20% discount they will give as a coupons for us. Most of us, we come across this experience. So they give the coupon. The meaning of coupon is when we come back after sometimes, when you come back and purchase again, you can redeem that coupons. The meaning there here is, already they had a prediction model. They have analyzed the customers who have bought earlier, who have given the coupon earlier, whether they have come or not. So here the prediction model works in such a way that if I give the coupons, for sure the customer will come and purchase again in my shop. So this is one example how do grocery cashiers know on the hand over to the coupon you might actually use. Sometimes we have different type of coupons. If you are working in the industry or if you are working in some other IT sectors, they used to give different coupons because they have a kind of tie up with the industries. So what they do, the coupon. So obviously we have to use the coupons, and the coupons will be redeemed and the suitable time. Even when we use the credit cards, based on the points, what they do, they have the tie up with the different e-commerce. Even they give the coupons for Amazons and the Flipkarts are different sites. So that we call as a prediction model. And here it is increasing nowadays. If you see if you compare the last 5 to 6 years and this year, you can see most of the industries have come into this picture saying that they'll give the coupons, because they had the predictions, they had the analysis, strong analysis. Actually, this will work out if we give the coupons to the customers. And here you can see one more example for the prescriptive analytics. The prescriptive analytics says, one example here, you can see the airline price. So it is not static, it is more dynamic, it changes very frequent time. How it happens? Purely based on the analytics. So let us take one example, like in Chennai. So at present, so just think like 100 users, 100 customers wants to travel from Chennai to Bangalore. So in a different location, virtually in a different location, they are trying to search a flight which flew from Chennai to Bangalore. What happens? So they capture all this information. They backend analytical tool captures all the information, saying that 100 customers, 100 person have been trying to find out the flight from the Chennai to Bangalore. So based on the demand, they change the air price. So this we call it as a prescriptive analytics. So I hope till here we try to understand the big data analytics with different example, and what are the different types of analytics we have understood from the examples. So in case if there is any questions, I'm happy to address the questions here. And also I would like to play a small video here to understand how this big data revolution has been started and where we are currently now. So let me go back and let me play a small video here. I hope this video is visible to all. Let me increase this. Ma'am, can I get a confirmation that are you able to hear the audio? There is any organizer? Can I?
So it is audible, sir.
Okay, thank you, sir. Thank you. So I'm going to play the video. So I request everyone to just listen to the video to understand how the big data revolution or how it is started, and where we are, what are the different skills is required to overcome this shortfall. Yes, I hope this video had made a kind of impression that how exactly the huge amount of data is getting generated. Even from the video, we understood that there are different sources where the data is getting generated, and we need a kind of a skilled person, or we need a kind of skill oriented persons with the different types of tools to capture and to analyze those data to give some values from a data. So I would like to stop here before I go with the next slide, in case if there is any questions. And even in the video, I hope you all understood that even nowadays IT sectors, they have worried about their projects, because the kind of the new trends coming into different technologies like machine learning, artificial intelligence, and the deep learning, different types of algorithm. Whenever, so you have many options now. So the person who is serving for the IT sector from last 15 years, if he's using the old tools, if you are using the old algorithms, if a new person, a student who is graduated this year or previous year, if they go with the solution for their existing problems, obviously they go for an updated version. So even the IT industries nowadays, they are facing a lot of issue with the existing person who is serving there from the last quite number of years, because they go with a later the previous version or the previous tools what they are using. But that's the reason always we say, like, every time the technology changes, the IT people also should update themselves. Even as a teaching community, even we need to update ourselves whenever the new technology born. So let me stop here, in case if there is any questions from the topic or from the slides which we have seen from morning. If you have any questions, you can ask me. Otherwise, I can go to the next slide. Yeah, so since it is just a small topic to describe the big data analytics, let us try to dig more little deeper now to understand what is the problem with traditional approach. See, this slide I've taken from Edureka, because I felt this is more relevant and it conveys the information to everyone. So that is the reason I have taken here. So the topic of this slide, you can see the problem with traditional approach. What exactly the problem? Why we need a kind of technology to handle our data? So if you see the first problem, the image explains here, the amount of storage what I have is very less, but the data what is coming to my system is very big, the huge amount of data. So the first problem here is storing a huge amount of data. It's not possible in the traditional approach. The second, here in the diagram, you can understand the traditional approach has it has all structured data, so that we can store easily. But when it comes to the big data, it has a combination of different types of data. So what is the second problem? The second problem is storing an heterogeneous data. So I have structured data, I have unstructured data, I have semi-structured data. Maybe you get a question saying that how much percent of data is available in the country or the world right now, which is structured or unstructured? Only less than 20%. I can say less than 20% of data is structured, and more than 80% of data is unstructured. So obviously the traditional approach will not be helpful for us to analyze the unstructured data. And here comes the third approach, third problem. So the third problem is, if I want to process some huge amount of data, what happens in a traditional approach? All the data which is stored here will be transferred to a centralized place where the processing will be taken place. So just an example here, I can say there are the three slaves. What happens? All the three slave has, just assume, let us have understanding like each machine have 10 TB of information. So which is trying to transfer to one place to have the analysis, to have the processing. What happens if, because if I have one slave here, what happens in case if there is any failure happens? Because we know that in a computer terminology, we know that if sometimes any natural disaster happens, also the data can be lost. And what happens if my data is lost when I start transferring from slave to the master where the processing will be taken place? So here the question comes like the storage and the processing. The third problem is accessing in the processing. How to access the huge amount of data? What the bandwidth is required? Here you can understand what is the bandwidth for each slave node need 10 TB of information to be transferred. Just think about the bandwidth required to transfer this information to one single node, and just think the time will be taken by a single node to process the information. So this wall, we call it as a problem, we call it as an accessing and the processing. So I hope from this three problems, the first problem, let me repeat again, the first problem is storing a huge amount of data is the first problem. And the second problem is having the different types of data. Big data has a different types of data where we need a kind of technology to store all these different types of data. And third problem is accessing and processing. So when I speak about the big data analytics, I told you the process goes like capturing the data, storing the data, and analyzing the data. When you capture the data, and when you're capturing the data, if there is no enough sufficient place to store this data, again the question mark comes. So these are the three problems broadly I can classify here. I can say with the problems with the traditional approach, and here we need to come with the solution how to address this problem. So that is what we are going to see the remaining time in the morning session and also in afternoon session to address all these problems. What are the technologies and what are the different tools and what are the different frameworks available for us to overcome this problem? If you ask this question, how to overcome this problem, there is a solution. There is a solution for us. The solution is an Adobe. And here the Adobe itself says which address all these three problems. When I say the storage part, when I say the heterogeneous part, when I say the accessing and the processing, so all these three problems which we classified broadly can be addressed by the framework and Adobe. So let us try to understand. I've given the introduction here. So before I start what is Hadoop, let us try to understand how it is going to help us. Our introduction to an topic. So in contemporary time, it is commonplace. So in nowadays, see in everyday day-to-day activity, in a day-to-day our lifestyle. So it is a common place to deal with a massive amount of data. Because in a day nowadays, after this COVID pandemic, the worst condition. So all our teaching community we are using nowadays the online sessions, and also the management says that we have to take a backup of all our classes. So what we do, we usually take the backup of our classes whatever we conduct in the online mode. So just think about the data, how much amount of data is getting generated. To be frank, in my laptop capacity is 1 terabyte. So in this semester itself, in this odd semester itself, almost I've collected more than 300 GB of data, only taking the backup of my classes. So it's really become a common place where we generate the data, and we are living with that commonplace now. So some of the example from your next WhatsApp messages, because nowadays as a teacher community we don't have any other mode of communication. To ask the students to join to the class, we take the mobile and we use the WhatsApp to communicate to the students. And some of us we use the Twitter. You are created day at every step when you are interacting with the technology. Whichever technology we take, whether we take an internet here, internet for conducting the online classes, we have a tool here, we generate the data. When we take mobile in our hand, we generate the data. So these are some of the common places. Now just try that is our individual. So but think about the population what we have and number of devices they use and different types of data they create. So we are the one who called data agents. So everyone have that question in the mind, what happened, but ever wonder how to handle such data? So as an individual we create very less amount of data, we never bothered about it. But the industries where they receive a huge amount of data, is it stored on a single machine? What happens if it is stored in a single machine, if it gets the failure? We have seen the previous slide. What happens the accessing and the processing if one node is fails? What if the machine fails? One of the node has gone down due to some social disaster, it has crashed. Will you lose your lovely 3 a.m. tweets? I told I have all my records in my laptop. If I lose that, there is no other option for me to store or retrieve back. So what I did to make my student to access all my recorded video, I have created a Gmail account. I have added all my recorded video in the Google Drive. So what I did, for every section I created one Gmail account because they need to have access to the class videos. So what I did, so I have put those information in some of the distributed environment. Even though my mission fails, I can able to get the data from my cloud. So here, if you ask this question, the answer is no, because already you might have thinking about the Hadoop, because Hadoop has all these benefits, the uses which we can able to get as a benefit. So here the pretty sure you are already thinking about the Hadoop. Let us step into Hadoop to understand how it is overcome these problems and how it is going to give the benefits for the customers and also for the companies. Yeah. So what is Hadoop? So Hadoop here, Hadoop transforming the business across the industries. So this I've told this statistics in the year 2012, but now in the year 2020, you can assume almost 10, almost out of 10, 7 or 8 into in the Hadoop framework. So almost every industries they're using for one or other reasons. They are not directly using this framework to run their business. For one or other reasons, always the industries that are using this Hadoop as a framework to capture the data. You take any kind of industry, you take the healthcare industry, you take the civil construction industry, you take any of the mechanical industries, you take IT industries, you take any kind of industries, even the agriculture, everywhere they're using this Hadoop to capture the data and to give some kind of insightful information. So here, the one important thing is big data stores, storing and fast processing. So here Hadoop as a distributed environment. So let us try to understand. Hadoop is an open source. Obviously, we all know that Hadoop is an open source framework created in the year 2005 that keeps and process big data in a distributed manner. That is one important thing here we need to the takeaway from this slide. So it runs the framework in the distributed manner on the large collection of hardware. You have a huge amount of nodes. Whenever I say nodes, it's nothing but a lab machine. So where we have a number of machines, all the machines will be connected together. We call it as a distributed manner. This is one important thing. And here, business solutions across domain and industry. You take any kind of business. That's the reason I told you. So we have different domains. We have different business. Everywhere this has the impact created by using an Hadoop. So low cost solution with an high fault tolerance, because here it is a open source. As I told, it is a open source. It's a free of cost. Anybody can access this. Anybody can process the data. And which is a fault tolerant. We are going to understand how it is going to be a fault tolerant, because in the traditional approach we have seen if one node fails, our data is lost. But how we are going to overcome this, let us step in detail. Let us try to dig little detail to understand how it is going to help us. Yeah. So before I go with detailed discussion of HDFS or Hadoop, so let me give some small journey how the Hadoop has invented, how it is started. So these are the two legends you can see on the screen. Towards the left hand side to me, you can see Duke Cutting is the one, and also towards right hand side you can see Mike Caffarilla. So they are the two legends who has invented this Hadoop, and their current role now. So Duke Cutting, this current role is chief architect at Cloudera and commuter at the Apache Software Foundation. And Caffarilla, his current position is an associate professor in the University of Michigan. So their journey started in the 2002 as they come up with a small project called as Nutshech. Was started by both of these legends, and slowly what happened, the Google have released the white paper on Google file system. So they have introduced the file system in the year 2003 by the Google, and in the journey 2004 you can see the Google have released the white paper on MapReduce. So here the processing to overcome the drawback of accessing in the processing, we are going to use the MapReduce. So in the year 2004 itself, the Google have released the white paper on the concept of MapReduce. And in mid 2004, Nuts was implemented NDFS and MapReduce. So they have come up with a different plan to run the data with a different architecture. And slowly from 2004 in 2006, the development of Hadoop started as a sub project of Nutshech. So here the intention is not to create an Hadoop from the small product Nutshech. So from the Nutshech, it's a baby of Nutshech, I can say. So Hadoop has born from this small project. And in year 2007, Yahoo started using Hadoop on 1,000 node cluster. As I told, all the data is distributed across the machines which is connected. So here in the year 2007 itself, Yahoo has started using the Hadoop. So they have used the Hadoop on 1000 node cluster. And here in 2008, you can see the Hadoop becomes a top level project at Apache. And mid 2008, Hadoop defended the supercomputer because with respect to the processing, because it has the capacity to have processing the huge amount of data with a less time. So it has overcome the supercomputing here in the year 2008. And here in the 2011, Apache releases the first stable version of Hadoop. So that is 1.x. 1.0, 1.001, 1.2. So the first stable version of Hadoop is released in the year 2011. And here in 2012, The second version of Hadoop is released with addition of one more component called as Ion, that was released in 2012 and 2017. Currently, the version which we are using is Hadoop 3.x, that was introduced in 2017. Hadoop 3.x was released, and the year 2020. Currently, we are using the version. The Hadoop version is 3.1.3. Is the latest version of an Hadoop, and every day there is an innovation happens. There is a platform where we can register ourselves. Apache for software foundation, we can register ourselves. All the updates, whatever we the updates which we happen here in the Hadoop will be getting as a notification for us. So obviously you can register yourself in the platform to get the recent updates. So this is the journey of these two legends, and currently they are in the different role. But the invention was started in the year 2002, and the stable version of 1 is released, and stable version of 2 and 3 also released. And now the world is using this Hadoop framework to capture the data and the processing the big data. Okay, so with that introduction to Hadoop and the history about the Hadoop, let us try to understand what are the components there in the Hadoop. So we have three problems. In a broadly we classified in the previous slides. We understood there are three problems. Let us try to understand how to address those three problems with the components. So here Hadoop is a framework that allows you to first store the big data. That framework that allows any different source to collect and to store the data in the Hadoop framework. That is the first benefit what it does, and it is in the distributed environment, so that you can process it in parallel. There are basically two components in the Hadoop, so that we can classify. Let us try to understand all this explanation by using these two components. So Hadoop is, again, I would like to classify into two parts. One is Hadoop HDFS, another one is MapReduce. So here Hadoop HDFS mainly addresses the storage part. The huge amount of data, the big data, can be stored here in the Hadoop. And here the MapReduce comes in the picture for processing the huge amount of data, or accessing the data, huge amount of data. So here from this slide, I would like to tell, afternoon session I'm going to focus on this MapReduce. The morning session we are going to see Hadoop HDFS. So how to store the huge amount of data, and how to, maybe after storing, how to store the different types of data also in the Hadoop HDFS. So our focus is now for morning session is on Hadoop HDFS. Okay, some of you can ask me the question, why this Hadoop speaks like this. So why industries are using? So what are the top 5 reasons organizations are using this Hadoop? So let us try to understand why the organization are using this Hadoop. So these are the 5 top reasons. The first one is low cost. It is an open source. Only you need to have a commodity systems, and you need to have some servers to run this Hadoop framework. And next one is a computing power. So it has a high computing power where you can able to store the big data, you can process the big data. When it comes to scalability, if I have a 500 node, if I have the yes, sorry,
sir,
please.
your screen is not visible, sir.
Let me check my once again.
Okay.
Maybe because of internet bandwidth, sometimes happens. Let me share it again, ma'am. Let me reshare it again. Can I get a confirmation? Is it visible, ma'am?
Yes, sir. Yes. Yes, visible, sir. Yes.
Thank you, sir. So here are the 5 top reasons why the industries or organizations are using this Hadoop. As I told, the first reason is a low cost, because it is an open source. We can easily download and we can able to install this framework in our machine. And the next comes the computation power, because it has the computation power is high, because it can able to read, or it can able to store the big data, and also it can able to process the big data in an efficient manner. And when it comes to third one, it's a scalability. Adding the nodes. If I'm running a cluster with 100 nodes, by adding one or few more nodes, or removing the few more nodes from the cluster, will be easy. So easily we can able to increase the scalability based on our data which is coming into the system. In case if I get a huge amount of data, if I predicted that huge amount of data is coming for next 1 hour or next day, so what I can do easily, I can able to scalable the cluster size easily. So There's a fourth benefit here. It is a storage flexibility. You can store the huge amount of data in the distributed environment. So where your data will be broken into the smaller pieces, and the data will be stored among all the nodes. And the fifth most important feature is data protection. So here Hadoop has a concept of a replication factor, where the user is wishing to store a particular group of data. So I have a block of data. So what is the problem in a traditional approach? If my block of data, let me just narrow down this topic. I have a block A. I have a block A data. I would like to store this data in a traditional approach. I have stored the data in one of the machine. So in a traditional approach, in case if there is any problem happen to that slave node at the machine, my data is lost. But here, how to address that issue is by having the replication factor. So block A information, if you're trying to store the block A information in Hadoop, so by default Hadoop has a replication factor of 3. So what happens, your data, my data, the block A data will have the 3 replications. So even one node fails, even the system executes by taking the data from the other nodes. Let us see the detailed discussion in the coming slide. But here we have a data protection, so that the data, so if I'm running a business, I can satisfy my customer only by providing 24/7 access to my data. For example, they have, so and here you can see the enterprises using Hadoop. So you can see the different types of enterprises: computer manufacturing, business services, finance, retail, wholesaler, education, government. Almost every different types of industries, they are using this Hadoop framework. And most of the leading industries, you can see here: Facebook, LinkedIn, IBM, Twitter, Amazon, Yahoo. So everyone are using this Hadoop framework. So this is one of the important slide, I can say, the reason why the industries are using this Hadoop, and which are the different industries that are using this Hadoop. So with this input, let us try to understand how exactly the Hadoop is going to give all these benefits for us. So first, before I explain the architecture or the different nodes what we have in Hadoop, let us try to understand the Hadoop distributed file system. So what happens if I'm a user, if I would like to store the data in the Hadoop framework? So it is difficult to maintain a huge amount of data in a single machine. That we addressed, that we have understood the failure also. Therefore, it becomes necessary to break down the data into smaller chunks and store it on multiple machines. I have a huge amount of data. The data will be broken down into smaller chunks. The data will be stored in the different nodes. Let us see how to do that. So file system that manages the storage across a network of machines are called as distributed file system. So I have a huge amount of data. I have a 1000 node cluster. All the 1000 node cluster is across the network. It has connected each other and performing this Hadoop operation. So we call it as a distributed file system. And the Hadoop distributed file system is a storage component of Hadoop. As I told, HDFS is going to address the storage part. So it is a component of Hadoop. All data stored on Hadoop is stored in the distributed manner. This is one example, just a small example I have given here. If I have a data, if I would like to store this data in a distributed manner, you can see here all the 4 nodes are connected each other virtually, and it is supporting to execute all the Hadoop operations. So here the huge amount of data is getting distributed across, and it will be stored in the distributed manner. So here the huge volume. So being a distributed file system, it is highly capable to store the petabyte of data without any glitches, because I have a petabyte of data, or I have 100 terabyte of data. Also parallelly I have 1000 node cluster. It's obviously easy to store all this 100 terabyte of information in 1000 cluster node. Okay, so here now from this previous slide, what important thing what we understood is, whenever we need to store a data into the Hadoop framework, our data has to be broken into smaller chunks. So now from the next slide, let us try to understand how Hadoop is going to break down our user data. Let us take like a client want to store the data into the Hadoop framework. How the client data is going to break down in a Hadoop, let us try to understand. Yes, so Hadoop distributed file system components. You can see here Hadoop has 2 main components. Broadly speaks, you have a data block and we have a nodes. So data block is nothing but the user or client which they would like to store this information. So let us try to focus on HDFS blocks. So here you can see HDFS break down the file into a smaller units, and each of this unit is stored in the different machine in the cluster. As an example I have given here, the size of the block is 120 MB. So this here we are using the Hadoop 2.x version. In Hadoop 1.x version, the size of each block is 64 MB, but here it is 128 MB in Hadoop 2.x version. So here each block, whatever the data we try to store it in the Hadoop, the data, if I have, just take an example, I have a file size of 512 MB. I have a file size of 512 MB. So this is my file. And if I wish to store this file in Hadoop architecture, my file will be broken into the chunks. I can see the first block is created with 128 MB, second block, third block, fourth block. This is nothing but a HDFS blocks. And here one more example I've given here. My data is 524 MB. So first 4 blocks you can see 128, 128, 128, 128. And I have left with only 12 MB. And Hadoop also compresses the space according to the left out data. So I just left with 12 MB data. So Hadoop has the block only to suit the 12 MB of data. It creates the block. This block, the fifth block, will not be a 128 MB block. It will be just a 12 MB block. So let me try to explain with one more example here. As I told, it is the Hadoop 2.x version and client. I'm the client. I would like to store the file called as example.txt, which has 514 MB. And here the client, whenever the client wants to store this information, Hadoop break down the file into smaller chunks. The first chunk A is created with 128 MB, and parallelly B also 128 MB, and finally you can see here A, B, C, D has 128 MB, but finally E has only 2 MB. That means, so the Hadoop has given the size, given the location, given the block size, which suits for the left out data. So left out data is just 2 MB out of this 514 MB. So the block will be created only by having this 2 MB. So now we understood the input data is broken into the chunks. So now, so what are the different nodes we have in Hadoop, and what are the different daemons? We can call it as the daemons of nodes. So here we can see I've listed in the 2 parts. One is MapReduce, because this I'm going to focus in the afternoon session. So now let us try to understand about these 3 nodes. So Hadoop distributed file system uses for storage. For storage purpose, we are going to see there are 3 different daemons available, or 3 different nodes I can say. The first one is a name node, second one is a secondary name node, third one is a data node. So let us try to understand what is the meaning of all these 3, maybe by taking some examples. We'll see in the coming slide. Yes. So here I have explained about 2 nodes. One is a name node, another one is a data node. So there will be data node. The name itself suggests the data node is nothing but a node which stores all the client's information, client data. Okay, so let us go one by one. So the first one, name node. So name node is here. The name node is nothing but a master daemon. If I say it is a master, all these data nodes are the slave nodes. You can see here slave daemons and the master daemons. So here the name node is nothing but a machine, or I can say it's a computer where has the information about all these data nodes. We can say it is a maintains and manage the data nodes. So name node, responsibility of the name node is to maintain and to manage all the data nodes. So how it happens? What information will be there in the name node? So name node will have the information about the data node number 1, about the data number 2, and all the other data node which is available in the cluster. What kind of information? You can see here records the metadata. For example, name node will have the information about the data node 1. Just let me assume this is a data node number 1. We'll have the information about the data node number 1, what kind of data is available in data node number 1, and what are the different permissions we have given. You can see here location of the block stored, the size of the files, the permission, and the hierarchy, etc. All this information will be stored here about each data node. We call it as a metadata. So name node will have the metadata about all the data nodes. As we all know, it is in the virtual environment. So you can see name node and the data node need not to be in one single place to run the execution. It can be in any virtual devices also. What happens? For example, if any of this data node fails, this data node fails, how this information will reach to name node? There is a concept called as heartbeat. There is a concept of called as heartbeat. Every data node, we understood that this is in the distributed environment. Every data node by default, it sends an heart signal. It sends a heartbeat signal from the data node to the name node. So name node receives an heartbeat signal from all the data nodes. With that information, the name node will come to know that data node is alive. In case if any of this data node fails to send the heartbeat to the name node, then a name node decides that the data node is having some issues, it is not accessible. So these are the content which will be available in the name node. Name node is nothing but a master daemon which has the metadata about all the data nodes, and also the name node receives the heartbeat from the data node. So let with this very minimum explanation I'm given, let us go step by step. So in the coming slide, I'll be explaining in detail about the name node and what are the different types of files available in the name node. We'll explain that later. But here, just to give the introduction to the three different nodes, the name node is a master daemon which has the content of all the data nodes. We call this a metadata. Let us go to the data node. So data node is nothing but a slave daemon which stores actual blocks. The user client has given some data. The data is broken into the chunks. We call it as a block. Actual user data will be stored in the data nodes, and it serves the read and write request. Whenever user want to write the data, it serves the request, and whenever user wants to read the data, it serves the request. So that is the use of name node and the data node. I'll come to the secondary name node later. So from this slide, we understood what is name node and what is data node. Okay, the same thing. What are the explanation I have given orally? I have listed here. Name node in HDFS. Name node operates in the master worker architecture. This means there is one master node and the several worker node in the cluster. If I take a cluster, there will be one name node and there will be multiple data nodes will be there. The master node is nothing but a name node which manages the file system namespace. Already we have explained this. Already we understood all this. I've just listed here. And here, yeah, as I told, I'm going to explain about name node in detail. So you can see here, name node has all those instructions, and also along with that, it has two files. One is fs image and the edit log. A name node is a node which has these two files. The file name is fs image and the edit log. Okay, let us try to understand what is the use of these two. What is the use of these two files? So fs image is a file which stores the information about the files and directories in the file system. Name node is a metadata which stores the metadata. Inside fs image, it contains all the information about the files and directories which is in the file system. And for files, it stores the replication level, modification, and access, because we have a blocks. It has the replication and also it has the permission level. And for directories, it stores the modification time and the permission. So these are the information will be contained in the fs image. And if you see the edit log, on the other hand, we have an edit log which keeps tracks on all the write operation that the client performs. Whatever the write operation if I performs in the Hadoop framework, all this information will be taken a backup, or the information will be collected by this edit log. If I do any modification, or if I do any deletion, or if I perform any new write operation, everything will be recorded in the file name called as edit log. This is regularly updated to a in-memory metadata to serve the read request. So whenever clients wants to read or write information to or from the HDFS, let us try to understand. I've just given a small flow here. Whenever user wants to read or write operation from or to the HDFS, what happens? So there is an edit log. What is the edit log? Edit log will have all the recent update happen to all the data nodes. So what happens? Edit log will give the information, This will connect to the name node, because edit node has the recent updates to the architecture. So name node returns the location of the blocks to the client. So this is nothing but a read request. If user wants to read a data from an Hadoop framework, so the name node will take information from the edit log, because edit log will have all the recent updates of the transaction. So that location will be given to the client. So client will get or access the data from the data nodes. So here the most important thing is the fs image and the edit log. So here we need to understand, in the name node there will be two files. In each file, the fs image stores all the information about the files and the directories which is stored in the architecture, and the edit log has the recent updates. And also edit log will give it gives the update to the fs image also. I'm going to explain that in the next slide. So here we understood about the name node, and here the data nodes. Data nodes are nothing but a worker node. They are an inexpensive commodity handler, because it is not expensive. By having a normal commodity hardware, we can run all the data nodes. Just we are using that node for storage purpose. Data node are responsible for storing. Yes, it stores actual data of the clients. It retrieves, replication, deleting, etc. This they periodically sense heartbeat. As I told, all the data nodes periodically sends the heartbeat to the name node to say that they are active and they are alive. So here, addition to this, so far we have seen the name node and so far we have seen the data node. Addition to this, there is also one more node called as secondary name node. So let us see what happens. What is the use of secondary name node? What type of information the secondary name node will have? So I'm going to explain that in the coming slide. So here, what I'm trying to explain the secondary name node. So see, we have multiple data nodes. Even if one data node fails, the data is available in another other data nodes. Easily we can access the data. But what happens if the name node fails? Because we have only one name node. So there should be some kind of backup should be taken, the content which is available in the name node. So here the secondary name node cannot replace the name node operation, but it can take the backup of all the content which is there in the name node to the secondary name node. So here you can see, first let me go through this statements, then I'll come to this animation thing and I'll explain. So secondary name node is another node present in the cluster whose main task is to regularly merge edit log with the FS image. So we know the name node has two files, FS image file and the edit log. So this, the job of the secondary name node is, because in FS image we'll come to know what are the files and what are the directories available. In an edit log we know what are the recent updates happen in the architecture. So the job of secondary name node is to combine these two files and produce the checkpoints of the primary in-memory file system metadata. So after merging both of this node, it provides the checkpoint where it can get the recent updates. But the checkpoint pointing procedure is computationally very expensive and requires a lot of memory, because it is going to combine the data. It is going to create a new file, a new set of data here, because by combining both the files, which is why the secondary name node runs on the separate node on the cluster. Because the name node, you may ask the question why the name node can't do this, because it requires some amount of time and requires the space also to store the combined information of FS image and the edit log. So after combining this information, we are going to update this information in the secondary name node. So let us see this diagram now. So here you can understand we have two nodes. One is the primary node, another one is the secondary name node. Primary node has two files, edit log and the FS image. And every frequent of time, FS image and edit log, the copy of that will be given to the secondary name node. And the secondary name node combines. You can see the secondary name node combines both this. It produces the checkpoint. And this checkpoint will be updated back. It will be updated back as a FS image and to the primary name node also. So primary and the secondary. Primary node is the one who is active in the architecture. So secondary name node takes the information from the primary name node, and it combines it and finally gives the checkpoint to this primary name node. So this operation taken place every frequent of time, and the purpose and the reason for taking backup is in case if this primary name node goes down. Just think, this has gone down for 1 hour. What happens whenever it comes back again to the architecture, again to the operation mode? So from the secondary name node, it can get the update and it can start executing the process. So here it is not going to replace the primary name node. The secondary name node task is just to get the updates from primary node from both the files and create the checkpoints to get the update of recent updates or all this information from the primary node. It's very simple, and here it is going to have the updated information. Secondary name node will have all this information which is there in the primary name node. So all the data are nothing but a metadata, information about the data nodes. Yeah, so here let us try to understand the replication factor in HDFS. So when I say the replication factor, the meaning of replication factor is to make the fault tolerant, to make the data availability all the time. So here now one of the best feature of HDFS is replication of the blocks, which makes it very reliable. What happens? See, obviously we all know that we are using the Gmail. Everyone, we are using the Gmail account, where the Gmail provides 15 GB of free space to store all our files. Okay, so this 15 GB of free space is given for individual user with the replication factor. So here we are storing the data. All our 15 GB of information will be storing in the cloud, and they are using the Adobe framework where our data are getting replicated, and whenever a particular machine goes down, even they can able to retrieve the information for us without any of the time. Maybe whenever we go and access the data, whenever we go and access the data in the Gmail, we never feel that it is there in the cloud. We feel that it is there in our laptop and the machine, we easily access it. But here how it happens, because they want to satisfy, they want to give a best service to the clients, because the client, whenever the client wants, even if I want to get my data midnight 12 a.m. Early morning 1 a.m., if I want to access my data, the data should be available. That is the kind of service they have to provide. To make that service to more efficient, more reliable to the customer, what we need to do, we have to have the replication here. So let us try to understand what is replication here. Replication of blocks. So HDFS is it's just a storage components. This is because every block stored in the file system in the replication replicated on the different data node in the cluster. If I want to store a block, example I've given here, if we have a 5 blocks of 128 MB each, that amount of data which consumes is 1920 MB. Because here you can see by default Adobe has 3 replicas, but this we can configure. When we install Adobe framework, we can configure that replication factor to lesser or the higher number. Here you can see I have 5 blocks, each blocks into 128 MB size, and number of times the blocks will repeat is 3. So total size is required is 1920 MB. Here you may get the question, why we need to use this very big storage to store the same data? So here, since the cost of buying the machine is much lower than the cost of losing the data. So if I want, if as I told, it is just nothing but a customer and the company understanding. So the company, if they want to satisfy the customer needs, because whenever we buy any space in the cloud, the meaning is that we want to access the data on go. To give the service to the customers, when you see the backend, the machines what they buy to storage, it is lesser when you compare with the losing of the data. So here you can see I have a block 1 which is stored in data node number 1. The replication of the block 1 you can see, which is stored in data number 2 and also data node number 4. Like this, all my 5 blocks, all my 4 blocks is again replicated, and it is stored in the different data nodes. So here the takeaway from this slide is how the replication happens, and how the replication, the size will be calculated here, and how the same data will be replicated in the different node. So here also one more example, I have given a replication factor. The same thing I explained here. I have 5 blocks, and all 5 blocks has the replication 2 times. It is replicated, block 1, block 1, block 1. Total 3 copies I have, block 3, block 3, block 3. So this one example I have given here, the diagram. And by default replication factor is 3, in which we can able to configure later. Yes. So here, and one more important thing we need to remember here is a rack awareness, because I hope most of you have seen the data center, Google data center, how it works. Also, we know about how the rack structure of rack available. Just assume this is the rack structure. You can see here I have 3 racks. All the 3 racks is more than 3 racks we have. Just here we have 3 racks which is connected to the core switch, and in each rack you can see there are a number of data nodes available. That means if I have a rack structure where I can be able to place all the nodes in the racks. So here Hadoop framework has an inbuilt rack awareness algorithm. Okay, so here the rack awareness algorithm is used replication storage in the trade-off between reliability and the read-write bandwidth. So these are the 2 important factors why they have come up with a rack awareness algorithm. So let us see here. To increase the reliability, we need to store block replicas on the different node, different rack and the different data node, because you may think I have 3 copies. If I store one copy in rack 1, another copy in rack 2, another copy in rack 3, you feel that it has a high reliability, because even if the entire rack goes down, I have a data in another rack, even I have the data in another rack. I have 2, 3, total 3 racks. I have the data in all the 3 racks. But in a parallelly, we need to check about the time or the read-write bandwidth which takes to have the replication. For example, currently I'm in rack number 1. Currently I'm in the rack number 1. I made the first copy here. See, if I want to travel from this particular rack to the next rack, because I'm taking the amount of data with me, so I'll take my data here and I'll go to this next rack. That means there is some kind of bandwidth will be used to travel from one rack to another rack. So this both may need to be balanced. So let us see how we are going to balance that by using the rack awareness algorithm. So here just it is a replication, but we need to understand how this rack awareness algorithm works. Yes, have come here. So here the rack awareness algorithm is inbuilt. It is an inbuilt algorithm. So we are just trying to understand how it works. But here the client have no no input to be given here. It does automatically, but we need to understand how this works. So the meaning of here, you can see I have 3 racks, I have 3 blocks. The block A, I've stored the first copy of block A in the rack number 1, node number 1. And the second copy of the block A and third copy of block A I've stored in the same rack, because to reduce the read-write bandwidth, okay, instead of I take this data and I go to the next rack, because it takes some time and it requires an internet bandwidth to take this data and to go with the next rack. So I'm going to reduce that by having the 2 copy in the same rack with the different nodes. You can see here in the rack 1 I have 4 nodes, 4 nodes, 4 nodes. I'm going to have the copy of data in a different node but in the same rack. This is one method. Here you can see block B. Block B, 2 copies stored in one rack and another copy is stored in the third rack. So like this, we need to balance both of this. It does automatically. So if I store block A in all the 3 different racks, it gives the high reliability, no doubt in that. But what happens about the bandwidth? Both we need to balance together. So that is the reason we put 2 copy in same rack and 1 copy in the different rack. So this happens automatically in the Hadoop framework. So here it is to improve the network performance and to prevent the loss of data. So it is nothing but reliability. This is nothing but a read-write bandwidth. Yes. So here comes a small architecture. I have tried to give a small architecture here, and I'm not going to explain anything here. Let us go to understand how this read-write up taken place. We know this is a name node, and we have all 3 data nodes. This is nothing but the blocks of data, and here we have the client, and here we have a heartbeat where each data node will send a heartbeat of a particular block to a name node saying that I'm alive, I'm performing my activity. Okay, so let us try to understand this architecture by taking an example like how to store the data into the architecture. So here Hadoop data store, just I've taken this diagram from the data flyer. So how the blocks will be replicated, the same thing. So the large size of data will be broken into the blocks. The blocks will be given to the name node. We call it as a master, and the master node distributes the data to all the data nodes. And the replication, the blocks are the replicator for the fault tolerant. The same block will be replicated here. When it happens, automatically the rack awareness algorithm will be run, and so that it happens, the replication happens perfectly. Yes. So from here, it is more important for us to understand in detail about how architecture works for the different activities. So if I have an architecture, so Hadoop has one more feature saying that write once, read any number of times. So you're going to write the data only for once, and you can read any number of times here. So to understand the first about the write architecture, so let us take a small example. Let us take a small example here. I have an example.txt. The file size is 248 MB. So this is the client information. But when try to store this client information in the architecture, what happens? It broke down into the smaller chunks. This 248 MB of data is broken into 2 blocks. Namely, we call it as a block A and block B. So first block is 120 MB and 28 MB, and second block is 120 MB. So this is our input for us. So let us see what are the different steps will be involved by performing this write architecture, by to write the data into the Hadoop architecture. So at first the HDFS client will reach out to the name node, because only the name node knows where exactly the space is available in the data nodes. So we'll reach out to the name node for a write request. I place a write request to the name node saying that I need to write a block A, block B in the architecture. What happens? The name node have all the information, because name node has the metadata. It has the information about all the data nodes, where exactly the space is available, where exactly the space is full. What happens? The name node will then grant the permission, and with that permission, it gives the IP address of all the data nodes. it will provide the IP address of the data nodes where the file blocks will be copied eventually. For example, for block A, for to store this block A, the name node has responded the IP address of data node number 1, IP address of data node number 4, IP address of data node number 6. And the same way for block B, 379. Because as default, by default, it will be 3 replicas. So we need a 3 copies to perform the replication, 3 IP address. So after getting this this basic information from the name node, so there will be 3 types of activities will be taken place. So I have explained here. The first step is setup of pipeline. The meaning here is it will try to fix the path from where I need to start the journey and where I need to end the journey. It's nothing but a Google map. So if I want to travel from the source to destination, what usually I do, I go to Google map, I say source and destination, and it will show me the path where exactly I need to travel. The same way here, it will set up the pipeline to travel in the architecture. So once the pipeline is set up, once it is set, next there will be a second step will be data streaming and replication. The meaning of data streaming and replication is I'm going to take the data along with me, I'm going to stream the data, and I'm going to have the replication in the architecture. So once you successfully done with first 2 steps, the last step is acknowledgement. So all the data nodes which the copy is stored in the data node will acknowledge back to the client, and the same information will be reached to name node also. So let us see all these 3 steps in detail by taking an example as an architecture. Yes. So here the first architecture, first diagram, what I've listed here is a setting up pipeline. So you can see here we have a client, we have the name node, we have the data nodes with respect to the switches. Inside the switches, we have different data nodes. So you can see the first step, the block A, block B. User client has the block A, block B. Let us try to understand for one single write. We'll take one small block and we'll try to understand how this happens. Because as we all know, it happens parallelly. Whichever the data I have, let it be n number of blocks, all the blocks write operation happens parallelly. But here, initially, let us try to understand how the single block write operation will be taken place. So block A. So user will place, step number 1, user will place a write request of block A to the name node. What happens? The name node will replay or grant the permission to the client by sending the data node number, IP address of the data node. Sure, in this case, data node number 1, 4, and 6 IP address has been forwarded to the client. And the client, what happens? The client have the information now. Now the client and the architecture, the Hadoop framework will set up the pipeline. So let us see how the pipeline will be fixed. So now the step number 3, the client will go to the core switch. The client should go to data node number 1. The client will go to the core switch. From core switch, it will go to the rack switch. From rack switch, it fixes the path of data node number 1. The path is fixed for data node number 1. Say after data node number 1, I should travel to data number 4. So data node number 4 is there in the different switch. So I need to go to core switch. Through core switch, I need to go to the rack switch, and then I need to go to data node number 4. Now the path is fixed. From here, again, I need to go to data node number 6. From 4, I will go to data node number 6. The path is fixed. Now all the 3 nodes will acknowledge or give the signal saying that they are ready to receive the data. So this we call it as setting up the pipeline. So the path is fixed. The path is fixed for streaming the data. So yeah, so we are on time. Let us continue. So here the path is fixed. So next, after this, what happens? The second step comes. The second step is nothing but data streaming and replication. The second step is nothing but data streaming and replication. So here you can see the client already, they know, the client knows the IP address of all the 3 data node. So what happens? We are going to take the data. So we are going to take the data, we'll go according to the path, the path is fixed, we are going to travel in the path, and I'm going to create the first copy, block A, replica 1. So here the first copy, block A, is stored here. Can you see here? Data node number 1, block A is stored. And I'm going to create a replication now. The data streaming has happened. Now I'm going to create the replication. The meaning of replication is I need to take the data along with me. From data node number 1, I need to take the data, I need to travel through core switch to the rack switch to the data node number 4. That we call it as a bandwidth. write bandwidth, because if I have a huge amount of data, if I travel among the different switches, it requires a lot of bandwidth. Okay, so I have traveled from the data node number 1, I went to the core switch. From core switch, I traveled to the data node number 4. The first copy of the replication is created successfully. From here, from data node number 4, I travel to data number 6, and the second replication copy is created successfully. Now, currently, we are in data node number 6. This we call it as data streaming and replication. We perform the data streaming and we perform the replication of the block A. Now, what is the third step? So once the data streaming happens, so we need kind of acknowledgement to that client and the name node, right? Name node should get the confirmation that whether all the blocks are stored and replication is created or not. So that is comes the third step. We call it as shutdown of pipeline. So here the meaning of shutdown of pipeline is nothing but it gives the acknowledgement. So currently we are in data node number 6. Can you see here? Data node number 6 gives the acknowledgement to the data node number 4, saying that successfully created the replica. And from data node number 4 goes to all the switches and goes to data node number 1. It says acknowledgement received from both data node number 4 and 6. That means both the replication is created successfully. And from the data node number 1, it goes back to the core switch and it goes to the client successfully. It is write request is placed successfully, and from there the confirmation will go to the name node and the metadata will be updated. This updated metadata will be stored in edit log. So initially FS image will have the information that block A will store in the architecture, but whatever you update, whatever you change, make what are the changes made to this architecture, always that will be stored in the edit log. The name node will have two files, that is FS image and the edit log. The edit log file will have this updated information that will get an updation from the client saying that successfully all the nodes, the block A node and the replication is created successfully. So that is what here pre-architecture, because I have not explained this architecture, because the architecture is better we can understand by the example. Here we perform the read request. So here we have performed one single write request. Am I right? So we took only one block, that is block, namely block A, and we try to set up the pipeline and perform the streaming and the replication. And third one is shut down the pipeline or acknowledgement. So this we did only for one. But what is the purpose of HDFS? Hadoop does everything in parallel in a distributed environment. So all the write requests whichever place at a time will happen parallelly. So let us try to understand that multiple write request. So here you can see the topic that I have given is multi write request. So all this happens in parallel, right? So everything happens in parallel. Whatever we have seen the steps which we have taken for single write, the same thing will be happen parallelly for both the write here. So here we have block A, block B. Here we have block A, block B, and client gives a request to the name node to store both the blocks. The name node will respond back with the data node number, IP address, and client start fixing the path, copying the file, and also streaming and also replication, finally also shut down the pipeline. So here you can see, if you observe this diagram, easily you can understand how the steps I've given. 1A for the A block, it reaches to the core switch, and you can see the next option is it goes to replace, it goes to have the first copy of the data into the data node number, and from there again it goes to 2A, it goes to data number 1 and the block A is copied, and it goes to data node number 4, block A is copied, and it goes to data number 6, block A is copied. The parallelly, even the block B also task will be taken place, because everything will be managed and monitored by the name node. Name node will give an IP address to the client so that all this operation can be taken place in parallel. Okay, so here let me stop here in case if there is any questions from the topics what we have seen. So far what we have seen, if I want to give a summary, if I want to tell the topic what we have seen. So we have seen the big data analytics. We understood how the big data amount of data is getting generated and what is meaning of analytics. And also we have seen the problems in traditional approach, and follow to that we understood how to overcome that by Hadoop, and we have seen the introduction to Hadoop, and we have seen Hadoop blocks, We have seen Hadoop architecture and what are the different nodes are there in the architecture, and how this architecture supports for write and read requests. Read requests I have not yet started. So how it performs for how it supports for write request. So these are the topics which we have seen till now. If there is any question or if there is any clarification required, so I'm really happy to address those questions. If there is any questions, you can raise, and you can use the chat box. Even the organizer can help me with the message which is there in the chat box.
Sir, somebody have posted a query in chat box, sir.
Yes, ma'am.
How machine learning related to big data?
Sorry, ma'am, can you repeat?
How machine learning related to big data? I think Padma Prabha have posted this query.
Yes, ma'am.
How?
Yes, ma'am. Yes, ma'am. I got it. Padma Priya,
Okay.
ma'am. Here, actually, the big data. Here, we are understanding the introduction to the big data, introduction to the platform. I can say Hadoop. For example, when you, for example, before you store the data into the Hadoop, or after storing the data into the Hadoop, if you want to analyze, so the machine learning has a different n number of algorithms are available. So there, the machine learning will come into the picture for the pre-processing or the post-processing. In case if you want to perform any kind of analytics, I told you, I've explained the slide called as types of analytics. So if you want to give some kind of analytics, either it can be a prescriptive analytics, it can be descriptive, or it can be a predictive analytics. So where the machine learning comes into the picture. So you can use for the prediction, there are k-means algorithms. There are many algorithms available for prediction model. We can use such algorithms, and we can able to use this platform for storing the data, and both can be worked together. So here, this topic, the introduction to Hadoop and the MapReduce framework, is how to store the huge amount of data into the architecture and how to process the data. If I have unstructured data, how to process the data. But in case if you want to wish to have any kind of analytics on this data, we can use an algorithms which is available in the machine learning and the deep learning. We can use that and we can execute. I hope that I addressed the question. Is there any other question, ma'am?
Sir, may I know about replication?
Yes, sir. Here the replication, as I told, here by default, the architecture has 3 replicas. So we can see, we can understand from this. By default, it will be 3 replicas in an architecture. But in case if you want to configure, we can configure when we install this Hadoop into our architecture. The Hadoop, when we install, we can configure this. But when I say the replication, so purely it depends on the rack awareness algorithm. There is an inbuilt rack awareness algorithm which automatically have the replications. It decides which particular data node should have the replication. For example, I have a block A. Here the user data is broken into the block A, block B, block C. The block A, initially the block A, the rack awareness algorithm gives the data node number 1 to store the first copy of the node block A. And subsequently, to store the remaining 2 replicas, it gives a different rack and also different data node. So that the replication of block A is created in data node number 6, and the second replication of block A is created in data node number 8. It happens by default, it happens automatically. So here, as a client, we don't have any option to say that how it is going to decide on the rack. But only thing we need to understand here is how this rack awareness algorithm works to improve this reliability and to improve the data loss. So to avoid the data loss, we need to understand this inbuilt rack awareness algorithm so that replication will be taken place, and also it will not move across all the racks. We can see here actual block is created here in the rack number 1 in data node number 1, and the remaining 2 block is stored in the same rack, because to avoid the bandwidth, to avoid the write bandwidth, because it takes some time and it takes some kind of the network also will be consumed from traveling from this rack to this rack. So to avoid that, both the copies have been pasted in one single rack itself. So here replication factor, again we can modify. So it is left to us, we can modify. But this replication factor, I'm speaking with respect to 2.x Hadoop version. But at the end of my presentation, in afternoon presentation, I'm going to give a comparison analysis of Hadoop 1.x, 2.x, and 3. So there we can understand how we are going to overcome this. Some of you may think, why need to use so much storage here to store the same data? So to address this question, we need to know what are the features in Hadoop 3.x. So that will be explained in today's afternoon session. So I hope I address the question of replication here. Is there any other question, ma'am?
No, sir.
Okay, thank you, ma'am. Thank you. So here, before I go with the next slide, I would like to give a small example or the case study to understand how some of the Gmail. Let us take one example as the Gmail itself. Gmail is free. They are giving the free space of 15 GB for all the users. So have you ever thought? Have you ever wondered why they have given for free of cost? What is the benefit for them? Anybody wants to add the points on this? So my question is, why Gmail is given 15 GB of free space for all the users? Because it is they're providing the virtual storage. We are trying to store all our personal information or our professional information in the drive. What is the purpose? What is the reason behind giving the free space to users? If anybody wants to add here, and anyone know anything about this? Why they are giving free of cost? That is my question. So here also it's purely performs the analytics. It's purely having the big data concept and analytics together they are having here. Because whenever, for example, whenever if I give one more example like Google Maps, if I'm using the Google Maps, nowadays the analytics is in the real-time scenario. For example, I'm traveling from source to destination. Just let us assume this is the time I'm traveling. Now the time is 11:45. I'm traveling from source to destination. It takes minimum 1 hour 30 minutes to reach my destination. What happens to use the Google Maps? Obviously, I should have a Gmail account. I should have a Google account. So what happens? The Google at the backend tool, as a backend to Google Analytics tool, it captures all the information about my travel. For example, I'm traveling from one place to another place. What happens? That information is captured at the back end, and whenever you travel towards the destination, if you are traveling towards the destination, you may get many notification, or you may get a different kind of notification saying that whenever you cross any kind of restaurant, the notification will come in the Google saying that there is a restaurant available in the next half a kilometer, and the rating of the restaurant will be 4-star, 5-star, and the reviews. So all this such information will be given as a notification for me, because at the back end the analytical tool has captured my information, and they started giving that information to the other agencies. So here the benefit for Google or the backend users will be 10 times more than what we are getting. So for us it is just a 15 GB of information, 15 GB of storage space, but the benefit what they are getting more than 10 times more than what we are facing now. So everywhere is a win-win situation at the mutual understanding, and a lot of analyticals nowadays. Hope whenever you have time, maybe you can go and see the Google accounts, Google analytical tool. It is an open source, it is a free of cost. What we can do, we can access this, we can use this Google analytical tool for the free of cost. If I am running a website, if I'm owning the website, if I want to know about my users, if I want to know about my users in and outflow, if I want to know about their likes and dislike, if I want to know about, if I'm running an e-commerce website, I want to know about how many customers have visited my product. So everything you can get it for the free of cost when you use this Google analytical tools for your website. So to demonstrate that, we have a Google demo account. If you just go to the Google, and if you just type Google demo account, you'll get a Google demo account which gives a clear explanation for what are the different types of dashboards they have, what are the different types of options they have, geographical options, about the users information. So it's really the technology is growing, and also most of them are performing the analytics. Even the small scale industries who is running the e-commerce business, a small scale industry, everyone that using some of the analytical tools to understand the users need, and also to give the benefits for the users. So everywhere, to store the huge amount of data, obviously they'll be using this Hadoop architecture for the Hadoop framework to store the data. So this is just an input or eye opener for you. Maybe you, whenever you find a time, you can have a research on this. You can go and find out why exactly the Gmail, they're providing 15 GB of data for us, and what are the different types of analytical tools are available to perform the analytics. As I told, Google Analytical Tools, it's a open source, it's a free of cost, and we have one something called as KISS matrices. Even there is also analytical tools, which is a paid version, but we can get an input from all these tools. So with that, let me go to the next. So here the same activity. So here this architecture explains about the HDFS read architecture. So if anybody wants to read the data, if client wants to read the data from the Hadoop framework, Hadoop architecture, what are the steps will be taken place? So client places a request to a name node saying that I need to perform a read request of block A and block B. And this information, the name node have the detailed study. Here what happens, name node will try to identify, is there any rack which has both these blocks? Because when I say the read bandwidth, if a client goes to reach to the particular server, a particular switch, if they're able to read both the blocks in same server or same rack, that reduces a lot of bandwidth. So now name node gives the response back to the client saying that IP address of data node number 1, IP address of data node number 3, where you can get a copy of block A and block B. So now client reaches to the core switch, and from core switch you can see here the block A and block B, both the blocks are available in the same rack. So it does automatically. Here based on the rack awareness algorithm, because of the rack inbuilt awareness algorithm, it happens automatically. Both block A and block B, both will be read by the user, that is a client, within the same rack, so which reduces a huge bandwidth here. So this is one example, like multiple read architecture, how read request works in the HDFS architecture. So this is one example, and here this is my last slide for the morning session. But before I end, before I give some time for the question and answer, so let me play a small video to understand how this big data analytics helps the education sector to capture the data and to analyze the data. So let us just try to listen to this video, and we'll see how this helping the teaching community and the management and the principal to capture the data and to understand how the students are doing, and easily we can able to perform the analysis, and finally we can come up with the insightful information.
Every 26 seconds, a student in America drops out of school, and more than 1,700 high schools across the country have a dropout rate above 40%. The sad irony is that most estimates predict that there will be more than 120 million highly skilled jobs in the U.S. by 2020. But American students will be qualified to fill less than half of those positions. These numbers can only spell disaster. But what if teachers had a more sophisticated way to monitor student progress? Education technology companies are now using big data analytics to give teachers a new tool to ensure success. Imagine a 10th grader incorrectly fills in the bubble for 6 apples, reevaluates, and then changes his answer to 12 bananas. We can now track the student's odds of flubbing this kind of question in the future and identify the flawed logic that caused the moment of doubt. Dozens of startups are using personalized testing to create detailed profiles for individual students, gathering roughly 10 million data points for every child. Arizona State University recently implemented a data analytics system that increased passing rates by 10%, while cutting dropout rates in half. These systems can also suggest exercises to make it easier for students to learn and hone new skills. Early adopters, like the Delaware Board of Education, reported an immediate 10% increase in both reading proficiency and math performance. And now more than 10,000 schools have integrated data collection into the classroom, which will soon help us answer some of the big questions. Many teachers resisted technology for decades because it often amounted to more work with unknown results. But new systems can provide analysis in real time, and more than 87% of teachers surveyed today believe that analytics can be a powerful instruction tool in the classroom. Big data is no longer just a measuring stick. It is allowing us to climb inside the minds of students to see not just what they learn, but how they learn best. Policymakers, teachers, and technology experts now agree that analytics are ready to tackle the problem. Will it be the catalyst that pushes American schools into the 21st century?
Yes. So here, I hope the video has explained how this big data analytics helps the education sector to overcome the shortfalls whatever we are facing in a recent time. See here, the in a video they have explained like almost when they started performing the analytics, big data analytics on the education sector, almost the 10% of the passing percentage has been increased and the 50% dropout ratio also increased. So here, so whenever the technology comes, as since we are in the same field, so I strongly believe that. So like maybe if you take any foreign universities or foreign institutes, so almost they perform the analytics, the big data concept, big data analytics in all the phases, starting from the admission and for the performance, even for the placement statistics, even for predicting the placements. So everywhere they use this big data analytics as a tool. But in India, slowly we started, and I wish that in future most of us should take some research on this area to come up with a different type of different types of areas we need to select, and we need to address the problems what we are facing real time, and the solution has to be come in the coming years. So that is what here. Let me conclude the morning session. So before I conclude, let me just give the summary what we have seen in from morning. So first, initially I told I'm going to give the introduction to the big data analytics. So we understood by taking a lot of examples, we understood how the big data is getting generated and how the analytics are going to perform and what are the types of analytics we have. And follow to that, we understood the problems in traditional approach, and to overcome those problems. So the solution we provided is Hadoop, and Hadoop has two components, as we have seen, this HDFS and the MapReduce. And we started understanding the Hadoop components, we call as the daemons, and we understood the data block size and how the client data will be broken into the chunks. And we understood about the replication factor, and also we understood about the rack awareness algorithm. And slowly we started with architecture, how to perform the read request and the write request by taking example of one single write and also multiple write request. So this is what I've explained from last 1.5 2 hours session, and this addresses the storage part. In afternoon session, we are going to focus on MapReduce concept, how the processing and how the accessing going to be overcome from the traditional approach to the big data here by using the MapReduce. So that is what we are going to address in the afternoon session. So I'll be happy if there is any questions from the participants. If there is any questions, you can raise the questions. I'll be happy to address.
Sir, can you explain about K-means clustering and prediction analysis?
So here, K-means clustering algorithm. See, so whenever if I want to perform any kind of analysis, see here the HTTP is frame the structure, schedule the structure in such a way that here have this slide this day today I have going to give the introduction to the big data analytics, and from this with this input when they start with the remaining session. So in a remaining session, I hope even the organizer can help with this. They have a different schedule to explain all the machine learning algorithms also, which includes the k-means clustering algorithm also. So here this session is purely given for the introduction to the big data analytics with respect to the Hadoop, HDFS, and the MapReduce. With this prerequisite knowledge, with this maybe in the coming days, they have a different schedule for machine learning, especially for the different algorithms. Maybe I can ask the organizer if there is. I think there is a separate schedule for machine learning algorithms, right? Can I know organizer can? Shivamani sir, it's not like here the plan is like to have the introduction to the HDFS and the MapReduce.
Okay, sir. I understand, sir. Thank you.
Yeah. With this, maybe in future, in the coming days, you will have the session on machine learning algorithms.
Okay, sure, sir. Thank you.
Yeah, thank you, sir.
Participants, if you have any queries, you may kindly ask.
So it's purely introduction. I know that most of you are aware of this, but here my intention or the organizer intention is to give the introduction to this two areas, that is HDFS and the MapReduce. That connects you to the remaining sessions to understand how this big data and also machine learning goes together.
Sir, if no queries, we will end the session, four-link session, sir.
Yes, ma'am. Sure. Thank you, ma'am.
Okay, sir. Thank you, participants. The session will be again start at 2 o'clock. I request the participants to join the session before 10 minutes. And one more information, feedback link will be given in the chat box below. Thank you.
Thank you, ma'am. Thank you, sir.